Hello, good evening. This is week 5 and this is Professor Khan, and I dedicate this week for us to practice some few problems. So I'll say it's week 5 and we are doing some problems for circuit in series and in parallel. I will say in series, voltage remain the same, voltage drop, current remain the same, and resistance adds up. So RT will equal R1 plus R2 plus R3. Okay, so let's consider this circuit here. This is my voltage, 120 volt, and we have 3 resistances in series. Let's say this is 10 ohm, 15 ohm, and 20 ohm. So what is the voltage here? It's going to be 120, and the current will be voltage over resistance total for that circuit. So R total will equal the sum of all of them, R1 plus R2 plus R3 equals 10 plus 15 plus 20. Okay, so that is equal 45 ohm, and the current will equal 120 over 45 equal, I'll use my calculator here, 120 over 45 equals 2.66, 2 digits are enough, 2.67 to round it up, amps. So this is very simple for resistances in series, and we'll do this in the lab as well to verify. Okay, that's the easy part. Okay, the more involved part will be resistances, parallel circuits. So let's take example again, 120, and let's write down first what happens. Voltage remain the same, current divide, and resistance will drop. Okay, let's see this example. I'll do 120 over here, and we have 3 resistances connected together, going back all the way to the origin. I will use the same numbers as last time just to show you how it will drop, and we'll say 10, 15, and 20. So how do I add these resistances? First of all, I'll say RT equal 10 plus 15 plus 20. Then I'll do the flip, which is 1 over RT equal 1 over 10 plus 1 over 15 plus 1 over 20. Divide 1 over RT, remain the same. 1 over 10 is 0.1. 1 over 15, use the calculator so you don't get confused. It's 0.067 plus 1 over 20, that's 0.05. Then add 1 over RT equals all of these together, 0.067 plus 0.1, and I got 0.217. Let me double check. So 0.1 plus 0.067 plus 0.05, and I got 2.7 ohm. So finally, flip again. Don't forget this part. So RT will equal 1 over 0.217. So 1 over 2 point sorry 0.217, and I got 4.6. That's enough. 1 ohm. So as you see, the voltage has dropped. It is smaller than the smallest one in the circuit, and if I want to find the voltage, is going to be the same. Current will equal voltage over resistance will equals 120 over 4.61 equals 26 amps. How do I know it's a circuit in series? Because the current comes from here and it divides. If you want to find the current in here, what will be the current here? That's 120 over 20. Just to prove my point, that's 6. What about here? That's 120 over 15. That's 8. And finally here, 120 over 10. That's 12. I add those three together. 12 plus 8 plus 6 should get 26 amps. See, the current has divided to the total of 26 amps. Okay, hopefully that makes sense. I'll do another example of a system with both series and parallel circuits. So let's consider this circuit now. Again, we'll start with 120, and I have a resistance, and I have those three resistances together, and I have another resistance all the way here. Let's call this 10 ohm, 10 ohm, 15 ohm, and 20 ohm, and 5 ohm. Okay, so the first thing when I look at the circuit is I will look and see what is the configuration. So from here I'll follow the current. It's the same. Then it divides in here. So we know these are in parallel, and this total resistance here is in series with this because it's getting the same current, and these currents will merge again to become the same current and go to the final resistance. So this circuit, these three resistances are in parallel with each other, but they are in series with those other two. So the first thing I do is solve for the parallel resistances, and if I want to solve for these, is going to be the same as this one because I did not change the values. So the total, our total here is equal 4.61 ohm. You see how it happens here? So I use the same resistances here, and it equals to 4.16 ohm. And so if I redrew this circuit, 120, I'll have 10 ohm, and the total of these three resistances, which is 4.61, and this is 5 ohm. So these three are in series, so our total will be 10 plus 4.61 plus 5 equals 19.61 ohm, and that's my circuit total resistance. And if I would like to find the current, it's 120 over RT, which equals 120 over 19.61 equals 6 0.11, so 112, I'm rounding up, and amps. Okay, I'll give you a second to look at it. Okay, hopefully this makes sense a little bit. I will do another example of a combination circuit just to make things a little bit clearer. Get some more paper. Just look at here. I'm gonna make another circuit with this, let's say 220. So this is 10 and 15, 10 and 15, ohm, 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 ohm. Okay, let's look at this circuit. It's a combination circuit. Why? Because those two are in parallel, and those two are in parallel, but this circuit and this circuit are in series. So I have to reduce this circuit to two resistances in series. So I'll take this circuit here and say R total equal 10 plus 15. I will flip 1 over RT equal 1 over 10 plus 1 over 15 equals 0.1 plus 0.05 0.067. This is 1 over 15. If I look at the calculator here, 1 over 15, 0.067. And the main reason of flipping is just to get rid of the fraction and get the decimal point. So this will be 0.167 ohm, 1 over RT. This is divide, FDA, add, then finally flip again. Don't forget this step. Everybody forgets this step. 1 over 0.167 equal, so 1 over 0.167, and I got 5.98 ohm. And if I look clearer here, this is smaller than these two, so I did not do a mistake. And if I want to redraw this circuit, it will look something like that. And notice I'm going to repeat the same process because those two are the same resistances. It just happens to be this way, just to make things a little easier and solidify the answer. So if I look at the same circuit, it's the same as before, but this time we have two resistances in series. I resolve this two into becoming 5.98 ohm, and this one will be 5.98 ohm, and to add them together equal 5.98 plus 5.98 all is 6. 5.98 times 2, I get 11.96, almost 12 ohms. So that's my total resistance for this circuit after it's been reduced. And I will find the current, which equals voltage over resistance, which equals 120 over 12 equal 10 amps. Okay, I hope you think this is doable and it is understandable. Okay, so let's take it up a little bit further. So let's say I want to find cost of running the circuit at 15 cents per hour per kilowatt. So 15 cents is usually what we pay, depending on your city. So let's say we're running this for a day. How would we do that? So this circuit, if we run it all day, we would love to know how much does it cost us to run. So we realize that this circuit, I'm gonna do it again here. This circuit is the current equal 10 amps for 24 hours. Cost is 15 cents per hour, 50 cents per kilowatt. Okay, so first we'll find the power for this circuit. Power equal voltage over current. What is the voltage? 120. The current we said is 10, so that's wrong, sorry. Power equals voltage times current equals 120 times 10, that is 1200 watts. Well, we said here that the cost is given by kilowatt. That's how much you pay. So I will convert this to kilowatt, equals 1200 over 1000, because one kilowatt is 1000 watt. So that is going to be 1.2 kilowatt. Good? Okay. 1.2 kilowatt. And let's see for a day. Cost per day equal 1.2 times 15 cents. 15 cents is $0.15. We agree? So $0.15 times 24 hours per day. So I'll do the math here. 1.2 times 0.15 times 24 equals $4 per day. $4.32 per day. So that is significant. If this is going to cost you 0.32 per day, how about for a week? For a week, we'll multiply by 7. It's going to cost you $30 per week. For a month, multiply by 4. That's $120 a month. For a year, which is 12 months, it's going to be $1,450 a year. This circuit will cost you this much to operate. Okay, I hope this makes sense. I will do another example of a combination circuit with the cost, just to make things a little bit clearer. Let's run an AC. I'm going to pretend that I know how to estimate the cost of an AC. So this is my circuit inside the AC, and I have current coming out, and I have my condenser fan motor and compressor. This is at resistance of let's say for a motor usually, let's say the fan is 25 ohms, and this is the resistance of, let's say, 15 ohm. Going further, and we have another control in it that is 10 ohms. This is my equipment coming here at 120 volts. I want to see how much this circuit is going to cost me to run for the month. Let's say a month. Okay, so first of all, I would like to know what is in series, what is in parallel. So this is in parallel because the circuit is currently going this way and forking up sideways, then coming back again. So this is in parallel, and this circuit and this circuit and this combination of resistance and this one are in series. So let's do the parallel ones. So I'll go with RT equal 15 plus 25, flip 1 over RT equal 1 over 15 plus 1 over 25 equals 0.067, and 1 over 25, this is 0.04, flip, divide, we did divide 1 over RT, then add 1 over RT equal 0.107, then finally flip again, and I got RT equal 1 over 0.07 equal 1 over 0.107, and I got 9.34 ohm. Then I'll add this total here. So this total here is 9.34 ohm, and as you can see, it's lower than this and lower than this. And then I'll add this together. So our total will equal 9.34 plus 10 from here, 10. So that is 19.34 ohm. So this is my circuit resistance. I'm gonna write it here. Resistance equal 19.34. Voltage is 120. Current will equal 120 over 19.34. And I got 6.2 amps. Okay, so I got the current. Now I have to find the power. Current times voltage equal 100, maybe consistent, 6.2 plus 120. So I have this number already here, times 120, and I got 744 watt, 0.5 watt. It's not bad. It's a lot. It sounds like a big AC, air conditioner. So this is the watt. Then find the kilowatt. So 744.5 over 1,000 will give me 0.7445. That's my kilowatt. So the cost at 15 cents cost for a month. So at 15 cents per kilowatt. So that will be cost equal 0.15 times 0.745. I guess approximated that to 5. Round up. Plus a month is 30. Okay? This is per hour. Kilowatt is kilowatt hour. So this is going to be for 24 hours per day, and that's for 30 days month. I multiply these together. 0.15 times 0.745 times 24 times 30, and I got, it will cost you $80.5 per month. Okay, I'll keep this on a little bit. So hopefully this makes sense. I hope you get to do some practice. I have put some practice problems on Blackboard for combination circuits. If you follow these tips, it should be clear. And I will be on the Hangout to answer any questions you may have. If you are consistently follow the numbers, then it should be fine. You can use the calculator, and please do practice these problems because they will be on the midterm and on the final. So I'll give you a problem. I wouldn't make it very complicated, something similar to this. I might change the configuration, but the first thing you have to resolve the combination circuit. Okay, from my experience, what are the common mistakes people do usually in these calculations? I'll tell you what. So the first mistake is not flipping at the end. Not flipping. So here the process is F, D, A, F. So flip, divide, add, and flip again. Flip is, you will have 1 over RT. You have to make it RT, and you divide everything in the results with by 1, kind of like what we did here. So this step, everybody almost forget. So make sure you don't forget that part. Second mistake. People see the circuit has a parallel circuit in it, and what they do is adding all resistances in parallel. So they will go here and I will do 15 plus 25 plus 10, and I'm gonna go and do flip our total, then flip, and 1 over 15 plus 1 over 25 plus 1 over 10, and they carry on and they get a different answer. And this is wrong because this 10 is in series with those two, not in parallel. So that's the second most common mistake. Third common mistake is people will go and look at this circuit, for example, and they will add, like adding everything in series, all resistances in series. I have seen that before. You do not add those all in series, it's only 2 in series. The other mistake I usually see in this type of problem, which one? There's so many of them now. Okay, yeah, in here. So what happens is they see those 2 in parallel and they add all 4 resistances in parallel, and that is going to be wrong because these 2 are in series with each other. So that's mistake number 3. So let's not please do that. Okay. Number 3, put it in here. Adding all resistances in series or in parallel. So follow these tips. First thing you do is recognize what is in series and what is in parallel. Resolve the parallel circuit. Then reduce the circuit to make things a little bit easier for you so you can see them correctly. Like for here, we did this one by itself. Then the other one is just happy to be the same. It could not be the same. You do the same steps for it and find the total for this resistance. I think this should make it a little bit clearer. And again, there are some practice problems and there are things in the book as well. Let me take a look at the book. So we're still in chapter 3. I'm taking my time in this chapter because it is very important. And the book doesn't go too much into this addition. So there's an example here. So there are 4. Let's see which page. So if you go to page 50, there are a few examples in the book about resistance in series and parallel. This is a shortcut to do the closer. It's a shortcut to show you how to do 2 resistances in parallel. It's easy, but it only works for 2 resistances. If you have more than one, you have to do it this way. More steps here, not a lot of examples, but I hope you have some. So let me know if you have any questions, and that's all I have for you for this week. Thank you.